Hey guys, this is Alex from Ignite Prep, and in this lesson we're going to be covering necessary assumption questions. Drawing from my experience as a tutor, I think students tend to find these questions really hard to completely master. And that's because there's a ton of variability in what the test writers can do with these arguments, what kind of reasoning structures they can throw your way, and what kind of traps you'll come across in the answer choices. With this question type, we are looking for two things, just kind of broadly. Number one, we want a really solid grasp of the substance of the argument. We want to be able to pinpoint exactly what our conclusion is and what information the stimulus is giving us to back it up. From there, we need to figure out what's missing from the stimulus. What information is left out that we would need to affirm our conclusion? So now with that intro out of the way, let's start to get into this lesson. First off, we're going to take a look at assumptions as a concept. Then we'll use that knowledge to work some practice problems and apply the concepts. So, necessary assumption questions are the head of what is called the assumption family, which includes necessary assumptions, sufficient assumptions, strengthen, weaken, and flaw. On their own, necessary assumptions really only make up about 10% of questions in logical reasoning. But because of the impact they have on all these other major question types, it's really important to have a strong footing with what an assumption actually is. And that's where we're going to start. Merriam-Webster defines an assumption as a fact or statement that is taken for granted. And I personally really like the last half of that definition, something that's taken for granted. Because to me, when someone says the word assumption or assumed, that's what comes to mind. It's something that someone just kind of takes to be true, even though it really doesn't have to be. The LSAT, however, gives us a pretty strict definition for what an assumption is. It's an unstated premise linking your stated premises to your conclusion. And that's really all it is. It's just another premise, something backing up your conclusion. The only difference is an assumption is not explicitly stated in your stimulus. That is the only difference between an assumption and a premise within the argument. So, now that we've tackled what an assumption is, let's talk about that necessary part. We call the necessary assumption necessary because if we don't have it, our conclusion fails. In other words, you need your assumption or else your conclusion goes kaput. Now that we know what an assumption is, let's figure out how to identify them when we're in our logical reasoning section. For this part, the question stems are pretty easy to identify. Most of them will have the word assumption or some variation of it, such as assumed or presumed or something like that. And then the other thing we're looking for in these stems are necessary indicators, which you can see off here to the right. They can say something like this. Which one of the following is an assumption on which the argument relies? You can see here that we've got the word assumed and the word relies. Okay, so our assumed is our assumption indicator, obviously, and then we have a necessary condition indicator, relies. Another example, which one of the following is an assumption that the argument depends on? Again, we have the word assumed as well as the necessary condition indicator, relies. So, up on the board, we have another few examples of these question stems. Just to recap, you can pretty easily identify these question types by looking for the word assumption as well as a necessary condition indicator. So beyond defining an assumption, there's actually a pretty handy way of figuring out which your necessary assumption is using conditional logic. If you haven't studied conditional logic yet, that's totally fine. When you do, circle back to this part and it'll definitely help with mastering these necessary assumption questions. So what we've got here is a classic conditional setup. We have our conclusion being our sufficient condition and our assumption the necessary condition. The placement of these here is super important because with a necessary assumption, we're actually not trying to make our conclusion 100% valid. What we are trying to do is fill in something to our argument that our conclusion needs in order to be possible. For example, let's say that we want to conclude that I'm driving. Something necessary for that to be true is that the keys are in my ignition. Okay? The keys in this case would be our necessary condition. Why? Well, look at it in reverse. Does having the keys in my car's ignition guarantee that I'm driving? No, I could just be sitting in a parking lot somewhere with the car on. But if I'm driving, can we guarantee that my keys are in the ignition? Yes, we can. Saying that my keys are in the ignition makes it possible for my conclusion to be true, which is that I'm driving. If we negate the assumption, the necessary assumption, and say my keys aren't in the ignition, then my conclusion is invalid. I definitely can't be driving. And that's all that necessary assumptions are trying to do. They're trying to add something in that allows our conclusion to be possible, not trying to prove the truth of our conclusion. In that last example, we talked about one of the kinds of assumptions present. And I think that's where a lot of other prep materials kind of steer you guys wrong. There's been this overemphasis on filling in gaps in reasoning when you have a whole other kind of necessary assumption floating out there. There are two kinds. Number one, the linking assumption, which is what we just talked about. That's when you're trying to fill in some kind of gap between your premises and your conclusion. But you also have the defending assumption, which basically is shooting down any kind of alternative possibilities beyond your conclusion. And we're going to get to those in a second. But for now, I want to draw your attention to something. Even though most people are trained to look for some kind of link between the conclusion and the evidence, you can actually see up here in this little graphic that linking assumptions actually only make up roughly 40% of necessary assumption questions, with the other 60% being these defending assumptions. So, if you are studying only linking, you are actually missing 60% of necessary assumption questions, which is 6% of your logical reasoning score. Not very good. Now that we've gotten that out of the way, we're going to take a deeper look at these linking assumptions. A great way to think of them is as a gap in the reasoning. You've got something mentioned in your premises that's not mentioned in your conclusion, or vice versa. So our linking assumption is going to work by gluing those two things together, okay? So here I have an example argument. It says, the iPhone has the best battery life, therefore it is the best phone. So, step one, this is where we start. What is my conclusion? Well, my conclusion is that the iPhone is the best phone. Step two, what's backing this up? That the iPhone has the best battery life, okay? But we're missing something. We're missing any link between battery life and what makes the best phone. If I came up to you on the street, there's a good chance that you probably wouldn't accept my argument as being valid. You'd probably ask me, well, why does the phone with the best battery life have to be the best phone? And that's a great point. There are so many other characteristics of a phone that would go into something being the best phone, right? You have battery life, fine, but you also have screen quality, the storage, the operating system, and a whole bunch of other things that go into that. Our argument only looks at one specific characteristic and then makes a big overarching conclusion based on this one characteristic. That's a pretty common LSAT pattern, and it's important that you learn to recognize it quickly and efficiently. Let's take a look at another one. All male Dobermans like ribeye steaks. Therefore, my dog Duke likes ribeyes. My linking assumption here is that Duke is a male Doberman. Okay, so be careful with that, because that's one place where the test writers are going to try and trip you up. It's not enough to just be a Doberman. You need to be a male Doberman, and that's going to connect my premises of being a male Doberman liking ribeyes to my conclusion that Duke does. All right? So I think in general, people tend to get this type of necessary assumption correct. They're pretty easy to master early on, because it's just so easy to spot that new piece of information that's being introduced in either your conclusion or your premises. If you see a new piece of information, such as my dog Duke, then it should kind of stick out to you like a sore thumb as a gap in the reasoning that you have to link to your conclusion. So, now that we've taken a look at assumptions that link to elements of a stimulus together, let's take a look at defending assumptions which protect your argument. I think most people tend to forget about these guys and look so hard for that linking assumption gap that they miss the fact that there's a defending assumption present. To start off, let's talk a little bit about arguments on the LSAT. Throughout the videos so far, I've said over and over that your job is never ever about contradicting the conclusion or the premises. Your job is to question the reasoning, the glue that sticks your premises and your conclusion together. But when you have an argument on the LSAT, the author of that argument believes that their argument's reasoning is valid. The author in writing their argument is making the assumption that there are no exceptions to what they're concluding. Those exceptions form the basis of defender necessary assumptions, okay? We'll go back to my example from before. If I say, the iPhone 13 Pro Max has the best battery life, therefore it's the best phone, you have to assume that there are no other factors that go into what's the best phone. What about screen quality and operating system and all that stuff we brought up before? Well, our linking assumption clearly links the idea of battery life and best phone, and we can use conditional logic to do things like that. The defending assumption, however, says things like this. Screen quality is not a consideration when deciding what's the best phone. Or operating systems are not a factor in judging phones and stuff like that. We're ruling out other things, and so defending assumptions tend to be kind of negative in tone. But you can see based off of that there is a lot of variability when it comes to the role of defending assumptions. They can pull all kinds of things out as possible reasonable exceptions and then rule them out, and you've got a defending assumptions. Before we move on to strategy, I want to do a little recap on the two types of necessary assumptions. We have a linking assumption, which links together a new idea or a topic in your stimulus. Those are the guys that bridge gaps in reasoning. We have an easy way to spot these. If you have some element in your premises that's not in your conclusion, or vice versa, boom, there's your linking assumption. Just stick them together, typically using conditional logic or something like that. Next, we have defending assumptions, which defend your argument against attacks. Put in more simpler terms, they rule out any other possible alternative that would weaken your conclusion. In general, I believe it's much easier to pre-phrase a linking assumption just because defending assumptions have so much that can go into them, so much that's possible that can attack the argument, and you can negate all of them and turn them into a defending assumption. So, what do I do to solve these questions? Well, they start with the two steps that every single question of the assumption family shares. Step 1, find the conclusion. Step 2, what's your premises? Next, we have to decide, is there an element present in your premises that's not present in your conclusion? If there is, then check for a linking assumption. If there's not, then we need to defend our argument. This is where flexibility and the confidence of strategy really pays off. You do not want to be locking yourself into a specific frame of mind when you're trying to come up with these assumptions before going to the answer choices. Instead, we're not pre-phrasing to look for an answer choice, we're pre-phrasing to get a better comprehension of our argument. What we need to do once we have that comprehension of the argument is take a look at your answer choices through the lens of that comprehension, rather than looking specifically for your pre-phrase. You want to go into your answer choices flexible. What impact does this answer choice have on the conclusion that I am given? LSAC wants you to feel defeated and stupid when you don't see your pre-phrase in the answer choices. They want you to think, oh, I just screwed up the pre-phrase, but you probably didn't. There's just so many possible pre-phrases that you could have come up with. It's not very likely for you or even for me to pre-phrase a majority of the time. So, stay flexible. Don't make excuses for dumb answer choices. Look at each answer choice and say, is this a possible defense of my argument, or is this just a related piece of information which maybe helps the argument, right? There's a distinction between necessary assumptions and strengthening questions. A lot of traps in necessary assumptions are not necessary for the argument. They either go too far or they do too little, but they're not necessary for your conclusion to be true. It's very important to keep in mind the goal of this question type. We want to be making our conclusion possible. Now, I have one last piece of strategy for you before we go to the trap answer patterns, and that's going to be the negation trick. Necessary assumption questions are one of the few question types that allows you to actually double check your answer choices. Okay, so before we get into this, let's take another look at what an assumption is. And to do this, we're going to use a math problem. And it's this: evidence plus assumption equals conclusion. This is one of the best ways that I've ever seen assumptions diagrammed. It shows you that the assumption is on the side of the evidence or the premises. Remember back to our definition of an assumption, it is the unstated premise or a unstated premise. But our assumption is necessary in order for the conclusion to be possible. Without our necessary assumption, our conclusion is impossible. So, if we negate the assumption and our conclusion is not possible, right, and we plug that into our math problem, evidence plus the negation of the assumption, we have no conclusion. So, how do we put this into practice? Take whatever answer choice you think is correct and negate it. If your conclusion falls apart and becomes impossible, then you have the correct answer, such as if my keys are not in the ignition. If your assumption is my keys are in the ignition, then the negation is my keys are not. All of a sudden, if my keys are not in the ignition, driving becomes impossible. Okay, so if after negating your answer choice, your conclusion is still possible, then you do not have the right answer for that question. Now, we talked a lot about negation in the existential quantifiers lesson, but let's just do a quick recap. When we negate something, we want the logical opposite of a statement, not the polar opposite. The logical opposite of cold is not cold. The polar opposite of cold is hot. If we take a look at some of examples of this, the logical opposite or negation of all is not all, which basically can mean anything from none to 99%. The logical opposite of some is not some, okay? Not all. I think a lot of people really struggle with negating necessary assumptions, And it has nothing to do with necessary assumptions. It has to do with our inability to negate existential quantifiers. And so if you feel like you're struggling with that, go back, recap them, diagram them out, make flashcards, do whatever you have to do, but make sure that you are 100% comfortable negating all of the existential quantifiers. Okay, so before we get into the practice questions, let's take a look at some trap answer patterns that are common within necessary assumption questions. First up, we have out of scope. These guys are going to be about a third of the wrong answers in necessary assumptions, so we have to stay really, really vigilant with what our scope is defined as and being in our stimulus guys. Okay? What they're going to be trying to get you to do is bring in some related, but not relevant to the conclusion, information. Then you also have answer choices that do the opposite and would actually weaken your argument, make it less likely to be true. Remember that the assumption is an unstated premise by definition, so whatever answer choice you pick should inherently be lending support to your conclusion. These opposite weakening traps are going to be about 15% of the trap answers and necessary assumption questions. Lastly, we have answer choices that are just way too strong. These typically deal with absolutes or extremes. You're going to very rarely have a necessary assumption answer choice that has an absolute, especially if your argument doesn't feature absolutes. And so absolutes make up roughly 5 to 10% of necessary assumption trap answers. All right? So now let's get into some practice and put a lot of the things we just learned into some application that you guys can use as a guide. Start mastering these question types. Okay, so our first one here is Practice Test 65, Section 4, Question 13, and it begins with educator. Reducing class sizes in our school district would require hiring more teachers. However, there is already a shortage of qualified teachers, so not just teachers, but qualified ones, in the region. Although students received more individualized instruction when classes are smaller, education suffers when teachers are underqualified. Therefore, reducing class sizes in our district would probably not improve overall student achievement. Okay, and so we have to start first. What's our conclusion? It's right here at the end with our conclusion indicator. Therefore, it's saying smaller classes would most likely not improve the quality of education. And what's backing that up? Well, we're told that if we want to make our class sizes smaller, then we need to hire more teachers. But we don't have enough qualified teachers within this region. Bad teachers don't help improve the quality of education, obviously. And at kind of face value, this sounds like the argument is pretty good. But we're being told that there's a shortage of qualified teachers in this specific region. You know, we don't have any evidence to tell us that maybe there's not qualified teachers elsewhere that would be willing to come in and fill this gap, right? Maybe the school district could go outside of the region, find qualified teachers, lure them in, and improve the quality of education that way. And so in this instance, we have to ask ourselves, is there a piece of information in the conclusion that's not mentioned in the premise? No, we have reducing class sizes, that's mentioned. We have improving student achievement, improving education, that's mentioned in the premises. And so we know in this question that we don't have a link that we're trying to make between our conclusion and our premises. And so instead, we know we have to defend it. And just now, I pointed out to you guys what a possible, alternative could be to this conclusion. And that would be the school district going out of the region to find qualified teachers and bringing them in. And so I'm going to go to my answer choices and look for something like that. A says class sizes in the school district should be reduced only if doing so would improve overall student achievement. Our educator is never making the argument about whether or not we actually should reduce the class size. His argument is just that if we would, so a hypothetical, it would not improve education, or most likely would not improve education. So answer choice A is out. Answer choice B says at least some qualified teachers in the school district would be able to improve the overall achievement of students in their classes if class sizes were reduced. That would be good if we were arguing that we're trying, or we could use smaller classes to improve student outcomes, but that's the opposite of what the author is trying to argue. And so B is definitely not necessary. B is doing the opposite to the argument, so B is out. Answer choice C says students place a greater value on having qualified teachers than on having smaller classes. This answer choice is kind of ridiculous. It's giving us this extra fact, but whether or not students value or students want something has absolutely nothing to do with the educator's argument. The educator's argument is talking about the effect of a hypothetical thing that they're trying to do, reducing class sizes. Students' desires or what students value is completely out of the scope of that, and so answer choice C is out. Answer choice D says, hiring more teachers would not improve the achievement of any students in the school district if most or all of the teachers hired were underqualified. So this is saying that underqualified teachers are going to help absolutely no one. We don't need that to be true for our argument. That's not necessary. If an underqualified teacher helps just one student, the author's conclusion does not fall apart, because the author's conclusion is about the overall student achievement within the district. One student being helped does not hurt that, and so answer choice D is not necessary. Which leaves us with answer choice E, saying qualified teachers could not be persuaded to relocate in significant numbers to the educator's region to take teaching jobs. So that is our defending assumption. It's taking an alternative possibility that qualified teachers could be persuaded to come into the district and negating it to protect the conclusion. So answer choice E is the correct answer and is our defending assumption. Okay, so our second one is Practice Test 65, Section 4, Question 20. And it says, when teaching art students about the use of color, teachers should use colored paper rather than paint in their demonstrations. Colored paper is preferable because it readily permits a repeated use of exactly the same color in different compositions, which allows for a precise comparison of that color's impact in varying contexts. With paint, however, it is difficult to mix exactly the same color twice, and the varying textures of the applied paint can interfere with the pure effect of the color itself. So step 1, what's my conclusion? Well, my conclusion is that art teachers should be using this colored paper instead of paint to be teaching color to their students. And why? Well, with colored paper, we can be much more consistent in replicating the exact same color over and over again than we can with paint. And so this allows teachers to show color in different contexts. Okay, and so hopefully when I said that last piece of the evidence, you guys caught that. We're never actually told that varying contexts is a good thing, right? Our conclusion is saying that colored paper is better than paint. But then in our evidence, we're told that we can get varying contexts from colored paper, and we need to link those two things. We need to say that varying contexts is a beneficial aspect of an art class or something like that, and we need to link that piece of our evidence to the conclusion. Okay? So if we go into our answer choices, answer choice A says, 2 pieces of paper of exactly the same color will have the same effect in a given context, even if they are of different textures. Our argument never mentioned different textures. We know that paper can be different, right? You know, you have different printing processes, or you can get different brands of paper, something like that. But, you know, it's definitely possible that our 2 different pieces of paper can have the same texture. So answer choice A is out. Answer choice B, a slight difference in the color of 2 pieces of paper is more difficult to notice than similar difference in the color of 2 samples of paint. Well, didn't our stimulus tell us that the 2 pieces of paper can have the same color? And so B seems to be kind of negating that or going against that. It definitely is not necessary for our argument, so we can take answer choice B out. Answer choice C, changing light conditions have less of an effect on the apparent color of a piece of paper than on the apparent color of a sample of paint. Apparent color is not really linked to our stimulus at all. Our stimulus is talking about the actual color of something. I guess this one is trying to loop you into how something is perceived, but our stimulus tells us that the color is going to look different in different contexts already, so answer choice C is out. Answer choice D, observing the impacts of colors across varying contexts helps students to learn about the use of color. And so answer choice D links this concept of varying contexts to the concept of colored paper being preferable. So answer choice D provides us with the link that we need. Answer choice E, it is important that art students understand how the effects of using colored paper in various compositions differ from those of using paint in those compositions. Our only purpose in the stimulus of using paper was to see color in different contexts. We do not care about anything beyond that use. It's out of scope. So answer choice E is out and D is our correct answer.